In the earlier lecture, we have studied about sequences. Now we will continue the topic with summation. So our topic was basically two subtopics. One was sequences and the other is summation. So for this, let's begin the topic. What do you mean by summation? So summation is actually related to the sum of the terms of the sequences. So if we have a sequence an, and the sequence an consists of the following numbers or the following terms am plus 1 and so on up to an, then for this sequence we are supposed to calculate the sum. So we use the notation j is equal to from the first term m till the last term n, calculate the sum. Sigma here denotes the summation. Or else we can also represent it as j is equal to m to n aj, or we can also write it as 1 less than or equal to j less than or equal to n aj when j begins with a1. That is, if we have our series as a1, a2 and so on up to an, then this is the sequence that is represented. And also, to represent our series, it can also be written as am plus am plus 1 plus and so on up to an. Okay, so in the earlier sequence that I've shown, I told that j is equal to m to n. Aj is written as the summation. So j here, it is known as the index of summation. It is known as the index of summation. Also, m is the lower limit while n is the upper limit. A large uppercase Greek letter sigma is used to denote the summation. So this is the Greek letter sigma. Now suppose if we want to find the sum of first 100 terms of sequence where an is equal to 1 by n. Let me write the question over here. So I want the sum of first 100 terms of sequence an. So of your sequences an, where what is an over here? An should be some term in n. So it is 1 by n. For what will be the, where should the n value begin? It should begin from 1, 2, 3 and so on. So it can be denoted by, so the solution can be written as, so we want the first 100 terms. So from, where is n beginning from? N is beginning from 1. So j is equal to 1 to 100, 1 by j. So 1 by j, why are we writing j? Because an was 1 by n. So since we are writing it in terms of j, it will be 1 by j. Similarly, another question can be, what is the value of sigma j is equal to 1 to 5 j square? So for this, we have to take it as 1 square plus 2 square plus 3 square plus 4 square plus 5 square. Why? Because we have j is equal to 1 to 5 and we want to find the sum. So it will be 1 plus 4 plus 9, 16 and 25, which will be equivalent to 55. Similarly, we can take another example as k is equal to 4 to 8 minus 1 power k. So basically over here I have the same term minus 1 and I am supposed to write it in powers of 4, 5, 6, 7, 8 and find the summation. So this can be written as minus 1 power 4 plus minus 1 power 5 plus minus 1 power 6 plus minus 1 power 7 plus minus 1 power 8. Now over here, if we remember, even powers give us the positive integer while odd powers will keep the sign as it is. So minus 1 excuse me. So over here we will have 1, then the next will be -1, +1, -1, and then +1. So these two and these two will get cancelled. The solution will be 1. Now, apart from that, we will see the progression, the summation of geometric progression. So over here, we have the formula given as follows. Summation of a geometric series is, if you remember, this was your geometric progression, GP, or geometric series, J is equal to 0 to n, AR power J is represented as, if R is equal to 1, then it will be n plus 1 into A. Okay, if R value is equal to 1. And if R value is not equal to 1, then this is the formula. For example, if we have taken the series is 2 power n, okay, and J is equal to 0 to 10. So this is basically 2 power J. Then we will have to substitute the value of n plus 1. So n plus 1, n value is this. So 2 power 10 plus 1 minus 1 by 2 minus 1. So it will be 2047. So this is the example, and even you have used this formula in your earlier classes. Now we have something known as double summation. So double summation is basically like a nested for loop. So example, I is equal to 1 to 4, j is equal to 1 to 3, ij. So to evaluate the sum, first what we have to do is I is equal to 1 to 4 is kept as it is, and the next we are supposed to do is we are supposed to put j value over here. So in the place of I, so we have ij over here, substitute the j values from 1 to 3. So 1i plus 2i plus 3i. After that, since we have I is equal to 1 to 4, so let's keep it as it is, I is equal to 1 to 4. And this is I plus 2i plus 3i, which is equal to 6i. So now this can be written as, now in place of I, keep substituting the value of I and adding it. 6 plus 1 plus 6 plus 2 plus 6 plus 3 plus 6 plus 4. So this will give you the result 60. Okay, so this is double summation. It works like a nested for loop. So this I can explain over here. So int sum is equal to 0. For int I is equal to 1 to 4 I plus plus, you are supposed to open another for loop, which is the second summation. J is equal to 1 to 3 j plus plus. Then sum is equal to sum plus I into j. Okay, so this will give you the same result. Now one of the most important summation formula is here series, this number series which begins from 1 to n. If you remember, it was given as n into n plus 1 by 2. Apart from that, the earlier formula for geometric series, which we have already seen, is very important. And then you also remember k is equal to 1 to n, k square, n square, n into n plus 1 into 2n plus 1 by 6. Okay. And then we have k cube is equal to n square into n plus 1 whole square by 4. And these are the important one apart from the geometric series. Now let's see an example with the same. Find sigma k is equal to 50 to 100 k square. Now for this, it can be found out by 50 to 100 means we have to take from 50 square to 100 square the sum. This is a bit difficult, so we will find basically k is equal to 1 to 100 k square. And how can we find it? K is equal to 1 to 49 k square plus k is equal to 50 to 100 k square. Now we have to find this, but it is difficult. So what we can do is we can find both of them, subtract it from each other, and we will get the result. So for this, let's take it k is equal to 50 to 100 can be written as So we are keeping it as it is, and we will k is equal to 1 to 100 k square minus k is equal to 1 to 49 k square. So this can be written as, if you remember, the formula was n into n plus 1 into 2n plus 1 by 6. So over here this is written as 100 into 101 into 201 by 6 minus 49 into 50 into 99 by 6. Whatever is the result, you can calculate it, but this is the way you solve the problem. Now we have cardinality. Cardinality is basically, if you remember, the number of elements in a set. So suppose if you have S and T, then the cardinality of both of these sets is same, or that we can say is it has 1-to-1 correspondence between the sets. So it has 1-to-1 correspondence between the sets. And a set that is either finite or has the same cardinality as the set of positive integers is called countable. So we'll see a few things. So these are infinite sets, okay, which cannot be counted, while 1 to 2, 2 to 4, 3 to 6, this is known as 1-to-1 correspondence. Countably infinite means elements can be listed. Anything that has the same cardinality as integers, example, rational numbers, ordered pairs of integers. Uncountably infinite is elements which cannot be listed, real numbers. Okay, so what is the difference? Over here, integers are called as countably infinite. That is, they are countable but they are infinite. While real numbers is 1.1, 1.01, 1.1.1, and so on. So these are not countable numbers. So this is considered as incountably infinite.